Hey y'all, welcome to our class today. It is Friday. We have made it to another Friday. Awesome job, y'all. I'm excited for today because we're taking what we've learned previously in with adding fractions with unlike denominators, and now we're going to talk about subtracting fractions with unlike denominators. So let's get started. But before we learn about and really build our understanding of subtracting numbers with different denominators, I want us to take a look at this problem. So I'll read it aloud, and then I'll get you started and let you work on this on your own. So Meredith went to the movies. She spent 2/5 of her money on a ticket and 3/7 of her money on popcorn. How much of her money did she spend? And once you solve that, figure out how much of her money is left. So if she spent money on a ticket and on popcorn, that means that and here we are going to need to add. So you're going to need to add 2/5 and 3/7. So what you need to do is add those together. And then I'm going to challenge you to figure out how much money is left. That second part is definitely going to push your brain, make it hurt maybe just a little bit, but that is good because that means you are learning and growing. If you have questions about this, let me know. But pause this video here, take on this problem, and I will see you when you are done. All right, y'all, great job on that problem. So proud of your hard work. Let's take a look at a subtraction problem. I want you to think about this problem, 1/3 minus 1/5. I don't want you to solve it. I just want you to think for the next about 25 seconds about how you could solve this. Feel free to talk it through with somebody at your house. If they're there with you, tell them how you'd solve it. We'll talk about it in just a moment. So I bet you probably remember that we have solved these using rectangular fraction models before. We had one model to represent 1/3 and one to represent 1/5. So we cut this one into thirds and this rectangle model into fifths. We shaded in part and then transposed them over here and over here. That would totally work. And we would do this to find our like units. Now what you've probably also started to realize is this is just like when we were finding our like units with adding. Like units are same denominators with adding. But if we did it with this rectangular fraction model, we would see that we would have 5/15 and we would have 3/15, and then we would subtract them. But if we did the same sort of thing that we did when we were adding fractions with unlike denominators numerically, we could list out our multiples, 3, 6, 9, 12, 15, 18, so on and so forth, and also 5, 10, 15, 20, so on and so forth. And we would see, hey, the number that appears in both of these lists is 15, so 15 is going to be our denominator. I bet you've also started to notice that if we multiply the two denominators we started with, 5 times 3, we also get 15. Interesting. So what are we trying to do here? We are trying to, and what we want to do in order to be able to solve this problem is create equivalent fractions. So we did that up here with our rectangular fraction models. But if we wanted to do it numerically, we could absolutely do this as well. So this is just like when we're adding fractions. We would do 1/3 equals something over 15. And then down here we would have 1/5, and I know I need to move this up, equals, something over 15. And then we would ask ourselves, 3 times what is 15? Well, 3 times 5 equals 15. And we know if we do something to the bottom, we also need to do it to the top. So we do 1 times 5, and 1 times 5 is 5. And we'll repeat this process with our second fraction. We'll say 5 times what is 15? Well, 5 times 3 is 15. And we know if we do it to the bottom, we also have to do it to the top. We did it to the denominator, so we need to do it to the numerator. 1 times 3 is 3. After that, all we need to do is subtract. So we have 5/15. Excuse me, minus 3/15. Minus 3/15. And that equals 2/15. Awesome. So the answer to our original question, 1/3 minus 1/5, is 2/15. I'm going to put that up at the top of my paper next to where it is. And I know you can't see that, but where you wrote 1/3 minus 1/5, you can write equals 2/15. Now it's time for us to try the second problem. If you feel up for taking this on your own, you absolutely can. If you'd rather us do it together, we can absolutely do that as well. So we're going to say 3/5 minus 1/6. And so we're going to list our units out, our multiples off to the side here. Our multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40, 45. And we'll do the same thing with our 6s. 6, 12, 18, 24, 30, so on and so forth. But I can stop at 30 because I've noticed that there's a 30 in both lists. I bet you also realized, well, there goes the cap to that marker. 5 times 6 equals 30. So now that we've found our like unit, our common denominator, we can go ahead and find our equivalent fraction. So we have 3/5 times something equals something over 30. We're going to ask ourselves, 5 times what is 30? 5 times 6 is 30. So we know if we do it to the bottom, we also need to do it to the top, because that is saying this times 1 is itself. So 3/5 times something, 3/5 times 1 is 3/5, but we're going to write 3/5 differently. Instead of writing 3/5, we're going to multiply. 5 times 6 is 30, and 3 times 6 is 18. These two fractions are equivalent. Equivalent, that means they are equal. They are the same amount. So then we'll go ahead and we will do the same thing with our 1/6. 6 times what is 30? Well, I know 6 times 5 is 30, and if we do it there, we also have to do it to the top. We're essentially multiplying these by 1. So 1 times 5 is 5. Our last step is to just add these together. So then we have 18 thirds. Sorry, not add them together, subtract them. Y'all, this was a subtraction problem, so we are going to subtract these. And, well, 18 thirtieths minus 5 thirtieths is 13 thirtieths. All right. So far, so good. Now, in order for us to be ready to go, we've thought a lot about the process, and we've thought about how to both add and subtract fractions with different denominators, different units, in different ways, with words and pictures, and now numerically. But I want us to put down the steps on paper so that we are able to follow those steps anytime we're working on these. And these will help you on your asynchronous day when you're working alone, so on Tuesdays and Thursdays, especially next week when there's a day that you won't be able to necessarily ask for help, want to make sure you have these steps written down. So we're going to take on this problem right here, 3/4 minus 3/5. Our first step is going to be to find the like unit. And there are two ways that we can do this. The first way would be to list the multiples. And we would have to list our multiples of 4. So 4, 8, 12, 16, 20, 24, 28, 32, that is an 8, 32, 36, 40. And our multiples of 5, where we would have 5, 10, 15, 20, 25, 30, 35, 40, 45. And I see two numbers that are in both lists. I see a 20 in both lists, and I see a 40 in both lists. So we know we want to use the smaller number just because it makes our lives a little bit easier. So the other way we can find our like unit, our common denominator, is to multiply the denominators. Multiply the denominators. And I realized I squished it a little bit there, but that is 4 times 5 equals 20. So at this point, we found our like unit, our common denominator, the denominator of what our fractions will need to be. So our second step is to create equivalent fractions. And that's where we're going to start with our fraction 3/4. And we're going to get to equal something over 20. And then we're also going to take our 3/5, and I'm going to change the colors on this one, and get it to have the unit or the denominator of 20. So for our orange, we're going to say 4 times what is 20? 4 times 5 is 20. But we know if we do it to the bottom, we must do it to the top, so everything stays equal. So we have 3 times 5, and 3 times 5 is 15. Then we'll repeat this process with our 3/5, trying to get to something over 20. 5 times what is 20? Absolutely, 5 times 4 is 20. And then we know we need to put a 4 up top because that means we're multiplying 3/5 times 1, because 4/4 is 1. Then 3 times 4 is 12. We have now created two equivalent fractions. We have 15/20ths, and we have 12/20ths. So our last step, today it'll be subtracting, but because this works for both, our third step is going to be add or subtract. And that says add or subtract. And then simply what we'll do is we'll say 15/20ths minus 12/20ths, and our answer is 3/20. Awesome, awesome job. Y'all, we're going to practice some more of this on Monday and really wrap up our adding and subtracting of fractions. We'll have a day of practice on Tuesday, and then Wednesday or Thursday of next week, we'll get ready for our next unit, and I'm super excited about that. Y'all are amazing. If you need anything, just let me know. Otherwise, I will see y'all soon. Goodbye.